Hello, and in our previous segment we showed how paleomagnetism, or the magnetism that is contained in old rocks, can show that the continents have moved in the past. All right, now what we want to do is to show how paleomagnetism can show that the ocean has spread. So we're going to try to show seafloor spreading through the use of magnetism. Okay, in the same way that you can go across the Atlantic Ocean from North America to Europe, and you can leave on your sonar, and then that shows you the mountains and stuff that's on the bottom of the ocean, you can also have a device that measures magnetism. So it's a magnetometer. So you attach this magnetometer to the bottom of your ship, and it shows you the strength of the magnetic field on the ocean floor. And so what they found were stripes. So they noticed that down the middle of the Atlantic Ocean was this series of mountains, okay? And then they noticed that on this side of the mountain range over here, they would find a strip of rock, maybe 10 or 20 miles wide, and all of the rocks in that strip were pointing in this direction, the same as the current magnetic field of the Earth. So in the previous segment, we talked about how rocks, when they're molten, they contain iron, minerals with iron in them, and then those minerals become aligned with the magnetic field as it exists at that time, and then when they cool off, they turn into solid rock. So they found rock over here that is oriented in that direction. Then on this side over here, they found a similar set of rocks, and it also has a magnetic field that's oriented like that. But then when they go over here, they found another segment of rocks. So again, this might be about 20 miles or so, where the rocks are oriented in the opposite direction. So what does this represent? So you end up with a series of stripes that goes across the Atlantic Ocean. Okay, and so what this represents is, you recall in the previous lesson, we said that approximately every 100,000 years, the magnetic field of the Earth reverses itself, and north becomes south and south becomes north. So that we don't know exactly how much longer it's going to take, but maybe in another 10 or 20,000 years, your compass will point south instead of point north. So the magnetic field flips about every 100,000 years. And when they dated these rocks, they found, lo and behold, that these rocks over here were about 100,000 years older than these rocks here. And the rocks on this side over here, well, they're oriented back the way that they're supposed to be, like that. So the little mineral crystals inside these rocks are pointing north, just like a little compass needle will point. Now, all you got to do is match the stripes up. So if we take these two stripes and we put them back together again, what does that do to the continents? So what that does is it makes North America and Europe get closer together when you do that. And if you take these two stripes, so let's see, this one and this one, and you put them together, it makes the continents get a little bit closer. So by putting these stripes together, we have, again, mapped out where the continents are located at and how they have moved around. So let's take a break, and when we come back, we're going to put it all together with plate tectonics.